Page 80. All right. So this is a review. What are the three conditions for continuity? What three things must be true for a function to be continuous at x is equal to c? You don't have to give it to me in math speak. You can just say it, the words. Okay, so the limit as x goes to z, c exists. What else? F of c is defined or exists. Say that again? Yes. The limit as x goes to c of f of x equals the value of f of c. That's what that means, right? All right. If you have those three things, then it's continuous. All right. At x is equal to c. I'm going to look at the last. So continuity on an open interval, you just have to be continuous everywhere on the open interval. So what that means is this. This is A, that's B. These can be undefined at A and B, but that's fine because it's an open interval. Because of the rounded brackets, we're not including those 2 points. Okay? Which is kind of obvious, I think, when you look at the graph. Closed interval, it's slightly different. Well, if you do it graphically, it would make sense, but we'll write it out and then we'll write it graphically. So you're continuous over the closed interval AB. Does everybody understand what I mean when I say closed and open? Right? Square brackets, we're including those numbers, so we say it's a closed interval. We're using the last 2 points, or the beginning and the last point. If it is continuous at every point within AB and the limit as x goes to A from the positive side is equal to f of A, and the limit as x goes to B from the negative side of f of x is equal to f of B. All that means is this. It's just fancy math words for this. The endpoints are defined, and there's no what I'm going to call like a floater point, right? It's not like this. That's why you have to say equals f of b, because if I did this and then did that, we're still defined at b, but it doesn't equal this. All right, so for it to be continuous over the closed interval, it's got to be a solid dot there at the end, and it's got to equal to the y value. So no floater points, I guess, if you want to say that, like that. Okay. We okay? We're not going to do that. Tell me if that function's continuous, please. We okay with that? Okay. This is a standard question too. Determine the value of k that would make this function continuous. So for it to be continuous, what must happen? Yeah, coming from this side, the left side, and the right side have to equal. There's only two definitions of your function here. So it means that when you're coming from the left side, x is less than or equal to 3, this has to equal that. So write that out in math. If I say two things have to equal each other, you just go, okay, 1 minus kx squared must equal 2 to the x plus 9. Now, that by itself looks like a gong show, but what makes it palatable? Do we know x? It's 3. So just plug in 3 and solve for k. 9 and 8, 17. Yeah, it's 17, right? Is that it? Negative 16 over 9? Did I do my algebra right? I don't know if I did it right. Did I? I'm just looking for validation here. Okay, so if k is 16 over 9, then it's continuous. That's all you do for those type of questions. Okay, you just set them equal to each other and you solve. Are we okay? We've done removable, non-removable. Ooh, this is a good one. So when you have trig, everybody loves trig. Find all removable discontinuities and non-removable discontinuities of the function. Look, there's only one point you have to worry about here. One, right? Okay. Tell me if it's removable or non-removable. Go. Remember, you don't have a calculator. You do have the graphs. No. They're just defining it that the absolute value of x is less than 1. So it's going to be a... No. Let's pull up the graph. I'll pull up the graph for you. You want to see the graph of this? Well, you know what the graph is. Sort of. Because it's going to be... Let you do this. I'll do Desmos. Where's Desmos? Is that the factored form? Okay, what cancels? X minus 5. So what happens at x minus 5? Yeah, so that's a POD. Therefore, x is equal to 5 is a POD. We don't care about that. We're worried about vertical asymptotes. We have a VA at x equals negative 6. Correct? Okay, they want us to describe what's happening at this vertical asymptote. In other words, which way is the function going? Is it both going up, both going down, or are they splitting in other directions? Okay. All right, so to do that, you have to do the limit as x goes to 6 from the positive side of x minus 3. What's left over? And the limit as x goes to 6 from the negative side of x minus 3 over x plus 6. Okay. What? Oh, negative 6. Sorry, thank you. Negative 6. Negative 6. Okay. Make this one clear. There we go. Okay. We know, so this is the notation that I was taught. We know the bottom's going to be 0, right? As you go to 6, it's going to 0 because 6 put in there, you get, or negative 6, you get 0. What you have to do first is figure out, is the top going to be positive or negative? I don't care what the number is. Is it going to be positive or negative? As we move towards negative 6. So if you come towards negative 6 from the positive side, just pick a number that's close to 6 but isn't negative 6. Negative 5. Okay. Negative 5. What's negative 5 minus 3? Negative 8. It's a negative number. It's always going to be a negative number if you're coming from that side. So it's negative. You can write the actual number, but all that really matters is it's negative. Now, this is the tricky part. You're coming towards negative 6 from the positive side. So as you move closer to it, is the bottom positive or negative? If I put negative 5 in here, if I put negative 5 in there, do I get a positive or a negative number? Positive, right? And as you get close to negative 6 from the positive side, they're always going to be positive numbers. Okay? So the notation that I use is 0 plus. It means it's 0, but you're coming at it from one side and it's always going to be positive. So we have a negative number divided by a positive number, which equals a negative number. Any number divided by 0 is infinity. All right? So this is going to negative infinity. Okay? Any number divided by 0 is infinity. Any constant over 0 is going to be positive or negative infinity. Because that's the definition of a vertical asymptote. I know you've been told you can't divide by 0, but you sort of can. All right? Now, we look at coming to negative 6 from the negative side. So we're coming this way. Number that's smaller than negative 6, negative 7. Top positive or negative? Negative. Top's always going to be negative. Essentially, well, depending. So negative. But you're coming at negative 6 from the negative side. So negative 6.1 works. Right? If I put negative 6.1 into here, do I get a positive or a negative number? A negative number. So now we have a negative divided by a negative, 0 negative, which gives me positive. And if you looked at this graph, it looks like this. Vertical asymptote at negative 6. You come at it from the positive side, you shoot down to negative infinity. You come at it from the negative side, you shoot up to positive infinity. And now everybody knows. All right, we're gonna do another one. We're gonna do another one. All right, this one's tricky. Okay. So cotan 2x over 0, 2 pi. What's cotan? Cosine over sine. So f of x is cosine 2x over sine 2x. Unless you've memorized the cotan graph, which I'm assuming most people have not, write it like this. Now, what's the only thing we actually care about if we're looking at vertical asymptotes for this graph? Do I care about cosine? No. Sine 2x cannot equal 0, right? Because if it does, then something weird's going on. So essentially, oh my gosh, sine 2x cannot equal 0. All right, people. Where does sine equal 0? We're on the domain 0 to pi. Where does sine equal 0? 0, 180, 360, right? So that means that 2x cannot equal 0, pi, 2 pi. Do you remember? This is trig 1, 2? I don't remember what it was. We have a b value. Is everybody with me so far? Okay, I'm solving for x. I don't want 2x. So what do? You divide everything by 2. So what does x give me? 0 over 2 is 0. Pi divided by 2 is pi over 2. 2 pi is pi. Look at how convenient that worked out. It's our domain. Okay, we have 3 points of discontinuity, right? Because if I put 0, pi over 2, or pi into this function, I get 0 in the denominator. Yes? Okay, so we have to look at, are we going to positive or negative infinity from each side? So this isn't going to be fun. So maybe it is. We do the lim as x goes to 0 from the positive side of cos 2x over sine 2x. And you got to do it for the negative side as well. But then we have to do it as we approach pi over 2 from the negative side and the positive side. And then we got to do pi. Yep. And the pi is actually not included in our domain, so we could just do the middle one, but we're going to do all of them just because I think it's good practice. And you all have scared looks in your eyes right now. Okay. We're coming towards 0 from the positive side. What's a number that's close to 0 but on the positive side of it? Let's do it in degrees. Remember, this is trig. You could do 1 degree. Okay, so cosine from the positive side. So we got to look at the top. Cos of 2x. If I put, well, if you look at cosine, where's the cosine graph? We're going towards 0 from the positive side. What's the value of the cosine graph? Because you're coming like this, right? Does that make sense to everybody? We're above the x-axis, so it's 1. It's positive. That's all I really care about, is it's positive. Positive. Sine function from the positive side, we're going to 0. Is it positive or negative? Positive. You're coming like this, right? It's above the x-axis. Does that make sense? So it's positive. So the bottom is like the 0 positive. So where are we going to? Positive infinity. Okay. Cosine, we're going to 0 from the negative side of 0. So the cosine graph, it's cut off here, but remember, it's like that, right? Coming towards 0 from the negative side. Is it positive or negative? Positive, because we're above the x-axis. Remember, we have no calculator, right? Okay. Sine function going towards 0 from the negative side. Remember, the sine function goes like this? We're coming at it from the negative side. Is it positive or negative? Negative, because you're coming up this line. So where are we going to? Okay, so as you approach 0 for this function, And the positive side is going to go to positive infinity, and the other side is going to go to negative infinity. All right. Sine, or the pi over 2. What's pi over 2 in degrees? 90. Okay. We're coming at 90 from the negative side. Okay, so what's well, we can just probably do cosine graph. But look at the function. It's 2x. Right? So that's another little wrinkle here. If you put pi over 2 in there, that is pi. But we're coming at it from the negative side. What's cosine of pi? Where's cosine? Cosine of pi from the negative side. So the negative side of 180. You're coming like numbers that are less. You're coming this way. Is it positive or negative? Then you put it into the sine function. It turns into 180, right? But you're coming at 180 sine from the negative side. Where's sine? Negative side, you're coming down this line because we're smaller than 180. So it's positive. Yes? Yeah, positive. So that's negative infinity, correct? Okay. Aren't these fun? Now we're coming at positive pi over 2. You put that in, so it's 180 pi. From the positive side of pi for cosine, it's still going to be negative, right? Negative. The bottom, I should put a 0. 0 plus 0 minus. Okay. Sine 180 from the positive side of 180. Where's sine? We're coming up this. So it's negative. So now we got negative over negative. So we're going to positive infinity. Okay. You try the last one. You already did it. What is going on here? And I put the graph up. You ready? Yeah. Okay. So should have been this. Wow. Oh, there we go. If you come from the positive side, you get positive infinity. If you come from the negative side, you go to negative infinity. All right, this is what the graph looks like. So as you come to 0 from the positive side, you go to positive infinity. Negative side, you shoot to negative infinity. This is 90. Positive side, negative side. This is pi, 180. Boom, boom. Okay? Is that fun? It's kind of neat though, isn't it? Nope, guess not. All right. Please do that one. we're almost done. I might have to do limits as x goes to infinity tomorrow. Well, it's not a might, it will. Did I do it right? I just did it quickly. So negative 4 is 3. 9 minus, yeah, that's right. Positive side is 5. Yeah, we're good. Yep. How did I get zeros for the negative positive? Well, if you're coming up 4 from the negative side of 4, so number 3.9. 3.9 minus 4 is a negative number. From the positive side, 4.1 minus 4. All right, we go, okay? I went a bazillion miles an hour. Here's some questions. We're not quite done. We'll finish it tomorrow. It won't take very long. I'll give you a big review package tomorrow, and then limits are over. Page 88, 5, 7, 29 to 43, odd, 65, 71. For 29 and 40, 29 and 31, it says graph them. You don't have to if you don't want to. But you can always use Desmos to check your limits. I'll do the limits as x goes to infinity tomorrow. Is that what you're going to ask? Yeah. There's a couple things left, and I'll do that quickly. Sorry I went so fast and I talked too much.